Do you see my screen?
Sir, it is not visible right now. Now it's coming up. Yeah, we can see your screen, sir.
Okay, I'll switch on my camera for a while, just to say, face to the voice.
So, Dr. Rajesh, give me, please, I would like to steal a moment before you start presenting your deliberation. I would like to be introduced to the audience here. Well, friends, very good morning. Very good to all of you, and very good morning to Dr. Rajesh Sharma. And he's associate professor in the department in the Institute of Computer Science at University of Tartu, Estonia. He has been also the adjunct holding the adjunct position of with Triple IT Delhi, India, and Lakehead University, Canada. Before that, Dr. Rajesh joined the University of Tartu in August 2017 and has worked as senior researcher till December 2019. And then before that, from January 2014 to July 2017, he has been holding the position of research fellow and postdoc positions at the University of Brussels, Queen's University, Belfast, UK, and University of Bologna, Italy. Prior to that, he completed his PhD from Nanyang Technological University, Singapore, which is a very, very prestigious university recognized across the globe. That was in December 2013. He has also worked in the IT industry for about 2.5 years. After completing his master's from IIT Roorkee, that is Indian Institute of Technology Roorkee. Right now, Dr. Rajesh is a leading computational social science scientist, and he's also leading a group called with the same name, Computational Social Science Group. This group works on the problems related to understanding user behaviors, especially using social media data, mobile call records, and business data. So today, we are very happy that Dr. Rajesh has very kindly consented to be here. Although I must tell you, this is the morning time for at approximately 7:30 a.m. in the country where he is residing, and this was on the basis of my special request. He has accepted our request to be online in such early hour. So we welcome you, Dr. Rajesh Sharma, to this 2 days national workshop titled Recent Trends in Data Science and AI. So, and I really thank you from the bottom of my from my heart, on behalf of the Department of Data Science and AI, that you could make it. Thank you so much. Over to you, Dr. Rajesh.
So your mic is not on.
Sir, please unmute yourself. Sir, please unmute yourself.
Can you hear me?
Yes, sir.
Okay. So thank you very much, Dr. Sood, for the introduction and for the invitation. I just want to say a small clarification that it's 8:30 because this Sunday we changed the clock. So the daylight saving thing happened, and now it's 8:30. So I don't want to take 1 hour extra of credit. So we are now 2.5 hours behind India. So India is in future. So you know that India is thriving, and it's a very exciting time to be in India. So I'm sure you all are doing very good. And again, coming back to the topic, what I will do is, because Dr. Sood told me that you guys already have a kind of basic to medium, maybe some of you are advanced, machine learning or other data science approaches. So what I will do is I will touch upon data science approaches, but mostly I'll be talking about various business problems and how we can connect to different data science approaches. But feel free to interrupt me at any point, and we can have a discussion during the presentation also. And later on, if you don't like something, or you should think that how these things could be improved, feel free to contact me. Okay. So again, can you see my slides? I just moved to the second one, right?
Yes, sir. We can see perfectly.
Yeah. Okay. Yeah. Okay. So I'm just using a kind of touch pen. I hope it works. So what my presentation is that I'll talk a little bit about where I am, my university, my group, and then I'll talk about business problems. And I'm just okay. Um, So where is Estonia? I was in Italy sometime some years back, and I thought people asked me, where are you from? And I said Estonia. They say, yes, we know Ethiopia. It's in Africa. So many of people don't know where is Estonia. So just for geographically challenged people, Estonia is here. So in the north you have Finland, and on the eastern side you have Russia. Here you have below Belarus and Poland, you have Ukraine. So we are very far away from war, but still, still touch our border with Russia. And this is the old town of Tallinn, which is the capital. Here is the capital, and here we are in Tartu. So University of Tartu is named after the city, and it's a second largest city of 90,000 people only. And just to connect with how much people know, or how much Estonia is covered in prior to war. So there was a question on KBC, Kaun Banega Crorepati. I guess you guys know that. So on 9th of September, there was a question which was asked that in Jan 2021, after the appointment of Kaya Kallas, which is the prime minister of the country right now, and she's still coming after the election, she will come back to power again, which is the only country in the world which has both the president and the prime ministers as females. So the right answer was Estonia. And I was thinking I could have won this 25 lakh because the person who was playing the game quit the game at this question. So I don't know how much you guys watch movies. So Christopher Nolan's, he's the guy, if you don't know him, maybe you have seen his movies Batman series. Okay, Christian Bale was the actor in that series. So his last movie or was Tenet. It's quite a nice movie, I must say. Watch it in theater, and this movie is heavily shot in Estonia, and especially Tallinn. So if you want to see Tallinn or the Estonia, I think you should watch that movie. So sorry if I behave like a tourism minister of here. And Dimple Kapadia, I think you know her, that she has a very important role in this movie. Another thing which is very common, that in Tartu, there was quite a powerful person. Power comes in various definitions. Either you could be politically power, or you could be financially very powerful. And in Tartu, in Estonia, there was a guy, Mr. Naresh Modi, who died because of COVID complications an year and a half back. He was quite powerful, and he shares his family name with the same powerful person in India also. We know who is the most powerful person in India with the same surname. Just the letter is different, the last letter. So just few fun things about Estonia and India. So University of Tartu, it comes in 251st rank in Times Higher Education, but the computer science department is between 200 to 250. There are around more than 1,000 students now, 120 employees, and these employees are divided into 6 chairs. For example, we have data science, software engineering, and security and cryptography, and so on. So this is the building of computer science department, and what you see here is the main building. And the university was started in 1632. And it was at that time it was a part of Swedish kingdom, because Estonia was part of various kingdoms, like sometimes in Sweden, sometimes in Poland, sometimes and most of the time Russia, but now it's finally an independent country. So what we have here is different kind of programs, bachelors, different kinds of master science, including the recently started data science masters, and then 4 years of PhD in computer science. Uh, Various companies which were founded by alumni of University of Tartu. I am sure you must have heard of Skype at some point. So Skype was developed by the alumni of Tartu University. Okay, later on, right now, it's acquired by Microsoft, and Microsoft has this habit of killing good products because it wants to, sell its own products like Teams. I'm sure some of you might be using Teams. Like Team is something like Zoom. So, and then you have a company called Bolt, which is something similar to Uber or Ola, what we have in India. Then you have TransferWise. I don't know if you have relatives. I know it's less in Himachal, but more in Punjab, that most of the people have their relatives outside, and they like to transfer the money. So TransferWise is an online version of Western Union money transfer, and the rates are very good. So if you have any relatives and they are sending money to you, you should tell them that use TransferWise next time. And then there are companies related to security like Nortel or Cybernetica and so on. Recently, I read an article that India is buying a kind of robotic security related stuff from Estonia. I'll talk briefly about my group, and sorry for the self promotion. So what we have is a computational social science group. So as Dr. Sood was describing, we are mostly using lots of computational techniques in societal issues. I'll talk about these issues in the second slide. So we have part of this group includes two assistant professors. Roshni, she recently joined in last December. Um, then we have presently 4 PhD students who are already in final year, and 2 will join soon. And then we have some of master students in our group, some interns, and some of these interns are from IIT Kharagpur and Ropar. We are open to work with, irrespective of your institute. We don't go after these labels. If someone of you, is interested, feel free to approach me. Then some of the alumni and already kind of plus 26 master theses have completed in our group. Some of them are working in Estonia itself, like Bolt, Skype. So Skype or Microsoft has its office in Tartu, and then Swedbank, and which is a financial institute, a bank, and some of them have gone out of Estonia, like London and Luxembourg and so on. So we have some openings for PhDs and postdocs. So if you or any of your friends are interested, please feel free to ask them to contact us. Take a note of email ID or the link to the group. We mostly work on topics like misinformation, hate speech, understanding mental health using online social media data. Generally, we gather this data from websites like Twitter, Reddit, and also like Telegram, because Telegram is very famous in East European countries. And we usually apply techniques like AI, NLP, and social network analysis. If you're an existing professor, postdocs, PhD, or master or bachelor students, we are always interested in working with you on interns, or we all sometimes we do have funding for PhD students. That is, they can come here physically for a short period. We can support your travel and weekly allowance here. And as I said, we are also interested in working with experienced researchers, professors, and so on. So what we do, I think I already mentioned that using understanding the user's behavior data, using financial and social media data, and online movements like protests and social things. We are also very much interested in this part, FEB, fairness, explainability, and biases. This is a very, very important topic, especially in Europe and US, because of new law which came in existence in 2018 or 19, which is called GDPR. Where basically every companies or organizations are kind of answerable to the customers. Customers have a right to know, for example, sometimes the bank institute, in financial institution like bank, they can deny a loan. They can deny a loan, and sometimes the data scientists, which are kind of encoding these programs behind creating these machine learning algorithms, they are not so conscious about some fields like ethnicity or zip code. And what the program can do is, like, it can become biased towards a certain field. That, let's say, if somebody lives in a certain locality in let's say Shimla, and I don't know much about Shimla, never been there. So if there is a locality called, let's suppose, Shakti Nagar, okay, and not very affluent people live there, and some people in the past from that area have applied for the loan and they got the loan, but they have not paid it back, so they have defaulted. So when the next time when somebody applies from Shakti Nagar, the program will see that the zip code lies in the Shakti Nagar, and because there are already 4 defaulters from that area, it will deny the loan. I mean, this might not happen in a small bank, but bigger financial, when nobody knows that which area and so on, the machine learning programs are used. So what happens is that the program is not fair, and it's biased towards a certain feature, and feature here is the zip code. Okay, or let's suppose if you put ethnicity, it not might be a case in India, but let's say in US, that certain people, let's say African American, if they live in the Queens area in New York, and mostly they are not so affluent. So if they are African American, and if that's a field or a feature in the program, you might say, oh, those people from this ethnicity might not repay the bank loan. So, and the program will say that don't give them the loan. So it's basically customers, if they know, they can sue the bank, because these are very sensitive features. You are not supposed to put it there in the machine learning programs. So what you need to know is the explainable, how the machine learning algorithms have concluded a certain decision. So this is very, very important. Okay, so this new area, which is like fairness, explainability, and biases, is very, very popular. So we are also working in this area. So not only using kind of a standard AI algorithm, but also on social media data. For example, if there is a thing called hate speech, then how the algorithm has detected that a certain individual is involved in hate speech. Okay. Now, we generally use other techniques like social network analysis, NLP, AI, and then explainable tools. What we do is we basically publish in journals like IEEE Transaction on Network Science Engineering, IEEE Transactions on Computational Social Systems, and so on, other data science and social network analysis journals, and some other conferences. Now I will move to the heat of this presentation, that is business data analytics using data science. So what is a data science? I mean, there are a lot of definition of data science, but and this term is a new term relatively compared to other terms, but basically this is a kind of umbrella term, I would call it. And within that, basically you are using a lot of data, and you are scientifically trying to understand what is there inside that data. Okay, so you cannot say that it's a heuristic approach, or it's like what your gut feeling tells you. No, you are relying on the data and you are trying to study this data scientifically using some statistical terms and so on. So it includes techniques like machine learning, deep learning, of course, big data processing, network science, or social network analysis, opinion, or if you want to call it a natural language processing, which includes things like sentiments, emotions, and so on. So this is a very broad term where, and you can see that in this definition that a lot of these techniques have already existed even decades back before this data science term became popular. And what I'm going to do is I will start with some basic definition, like what do we mean by business data analytics, why we need it, how to approach it, and then some of the problem or use cases in which we can use data science. So the first part, what is business data analytics? So basically you are analyzing the business data to generate revenues or profits for your institution, right? So of course you need it because you would like to increase the profit. Okay, and what are the different applications? I will discuss them in the coming slides. There are a lot of use cases. We will talk about it, and how it works, which is there in the next slide. So there is a concept called CRISP-DM. Basically, it stands for Cross Industry Standard for Data Mining. And what happens is that this is a very broad term, and there are around 28 processes which happens in that. But just to make our life simple, we have kind of congested them, or let's say make them into six or six steps. And it happens like this, that first we define the project. So think like this, that Geo is happy with the revenues it is generating, but then vice president of Geo, I hope you know Geo is a popular service provider, mobile service provider in India, and it says that I would like to generate more revenues, and the idea is that can we introduce new features in let's say Geo app, and that will help us in increasing the profit. Okay, so it says first the problem has been defined at a very high level by vice president, sales and marketing, and so on. And first of all, the step is examine the data, whether this idea can work. Okay, so let's think about maybe some of, I don't know how many of you are single, but some of you might see this, might have used this app called Tinder, right? So now Tinder, in basically there are certain limited features that you could use, but let's suppose in this kind of online dating apps, the customer will say, okay, if I would like to say that if you want to use these extra features, you have to pay, let's say, 150 rupees per month. And so some data scientists will examine the data, that how many of you this particular let's say if we introduce this feature, how much it will become popular, or whether people have a tendency to use it. So to introduce that feature, somebody has to examine the existing data. What is the existing pattern that somebody's there in the data set, right? Or if the data set is good enough, it gives you an indication that yes, this particular feature, people tend to have a video call before they meet in real. Then maybe what we should do is that with every video call, we introduce 10 rupees. So instead of 150 per month, maybe we should say that 10 rupees per video call. It makes life safer, right? You are seeing the person on video, and then it makes that, yes, this is the person, this is not the catfishing happening. And so these kind of things, first you have to examine the data. It may happen that the data needs to be fixed. For example, coming back to a financial institution, now there are certain fields when you fill the bank form. Certain fields are optional, but and certain fields are mandatory. Now, the optional fields, for example, could be your address, okay, your zip code, or your income. And if, let's suppose, 90% or 95% of the people are not filling their zip code, it means that particular feature has lot of missing data, right? And if that field is something like this, you might would like to take out that feature, that no, this feature which has 95% or above of the cells are missing, I don't think this feature is going to be important if you are trying to make a generalized model. Okay, so these are the things that you can fix in data. After fixing the data, you start creating models. If this term model is not clear, it will become clear in a moment. And then whatever model that you have used, you would like to assess it, right? You would like to evaluate the quality of that model, whether this model is going to behave nicely, what is the robustness of this model, what is the accuracy. Now, the term accuracy I'm using here is in a very generic sense. If you are happy or satisfied with the goodness of the model, you will put it into deployment. And if not, you go back, maybe you change the feature, or you might go here and you say, okay, might be something, I didn't fix things in this data well, so I need to fix that. Now, these things, that is business understanding and who are involved. Now, generally in companies like startups, you don't have different roles, but in a bigger institution or bigger organizations, you have different people who are dealing with different things, right? So the business owner, or the very high level at the hierarchy of the management, these are the people who generally introduce this kind of business objective, okay. So then you basically formulate the question, and then there is a domain experts. So, and then data analysts are different from domain experts sometimes. For example, think about a biomedical institution, right? A data analyst or data scientist might not know the terms like DNA, RNA. So you might would have a bioinformatics person or biomedical person who will try to tell these analysts that these terms or these features are super important. And same might happen in a settings like financial institution. And then basically this each of these understanding is corresponding to different roles, and these are then you have data steward and DB expert, database experts, because in very large institutions, when you have millions and billions of customers, you don't store your data in one single table, right? The data is divided into multiple tables and in DBs and so on. And the role of the data steward or DB expert is to, when you are trying to see the viability of this feature, viability of introduction of a certain feature in the app, for example, the data has to be analyzed first, whether this makes sense or not. Okay, so what happens is that this data, which is divided into different tables in your DB, the DB expert will bring that, okay, this table has this particular feature, another table has another feature, and so on, and it will bring it up and it will combine into a new comma separated file, CSV. Okay, and this CSV file will be analyzed by data analyst, and so on. So these are the different roles of people, and these are the different kind of steps that we are analyzing. So what are the different main sources of data? So generally companies, they look at their own customers data, which is kind of subscription based, in the sense that, think about, again, you're using a debit card or a credit card. The bank will know what's your age, what is your income. They also know your address. These are kind of essential fields. And or if you are going to bigger supermarket chains, and these supermarket chains have this certain card which you generally tap, and if you tap it, you get some kind of concessions. But basically, through that, companies are trying to understand your buying patterns, like what is your monthly or weekly buying patterns. You tend to buy bread more, or you are vegetarian, or you are non-vegetarian, what kind of drinks you like to buy, and so on. Okay. Or if we come back to the credit card or debit card, what kind of buying patterns, how much you fly, okay, and so on. The companies are also interested on social media data, which is not directly controlled by the companies themselves, platforms like Twitter, tech posts, and so on. Why they are interested? To understand what customers are in general talking about the companies, right? So and to see the difference, that the data which is in the possession of the companies, it's a more like a customer transactional data, okay, and these are coming from CRMs, and it's a more structured data. You can store it in a tables or database or comma separated CSV files. You can encode them well, okay. They are generally labeled in the sense that there are certain feature, and then the last feature, or let's say, it tells that the customer is a high income customer. That could be a label. Or the customer will not churn basically means the customer has not left the organization. Sorry, churn means the customer has left the organization, and non-churn means is still with the organization. Okay. So the data out of possession is generally very big, okay, and generally it has issues like veracity. Veracity means you don't know whether this data is authentic, whether you can trust it. Okay, there could be a lot of messiness in the data. Okay, we also sometimes don't know what meaning or the value we can get out of this data. And it's a mostly unstructured data. For example, Twitter, if you want to understand, let's say, Samsung battery issue. I think a few years back, you might recall there was an issue with the Samsung batteries, and they were exploding, and people were denied, even in the airlines. So a lot of people started tweeting about it, and it brought the bad brand value for the company. Similarly, in 2015 or 16, there was a Volkswagen scandal issue. I don't know if you remember, there was a emission scandal, and that brought a lot of bad name to the brand value of the and so the companies, they are always analyzing the data, that what is happening. And generally from Twitter, you have, like, although now 248 or so characters, but then you also have people using non-grammatical sentences, using emojis, emoticons, and so on. So it means you need new approaches to analyze this data. Now, while in academic institutes, we think that, or we might see that our journey on data analysis is like going to be like this, but it's generally not that smooth. There are a lot of hiccups that we have to see. And so just to understand, now, when you have the data, you basically spend some time in cleaning the data. You do some analysis of the data, either through descriptive analysis or doing some kind of visualization. And once you think that your data is clean enough, you apply some data science approaches. And if we have to think from machine learning perspective, you will bring this 4 to 5 lines of code from scikit-learn. you divide the data into test and train, you fit the model, then you evaluate using some metrics, and if the data is good, you basically start interpreting the results, and if that model is good, you try it into deployment. Okay, now this part is actually the part where most of the time is spent. 80% of the time is spent in this data, in analyzing the data, in cleaning the data. But before moving there, we almost think that, oh, data analyst job is mostly writing this kind of 4 lines of code and it will make our life happy. Okay. Again, data understanding and preparation, that basically, when you are, before you jumping on to make any conclusion, what you do is you basically, think about what could be the different sources from where you have to collect the data, and you have to integrate either from external sources or within the, if the data is possessed by the companies, they have to think that what are the different tables from where the data has to be combined, right? What are the important features that need to be considered, right? If the data is too big, then you might have to sample the data, right? And then you have to deal with data quality issues, do some basic stats, okay? And if the data has some missing values, you would like to do some kind of data exploration, just to investigate the data, you would like to see what kind of distribution of a certain feature is there. The data is whether skewed or not. Maybe you have to transform the data into different types, such as logging the data, creating kind of binning the data, and so on. Also handling the missing values, and then also deriving some, doing some feature engineering if the data is not rich enough. I mentioned about modeling. Just a moment. Okay. So there was a step called modeling. So think like this, that your data is to make our life easy. Let's think like that the data is presented in a CSV format, or comma separated values, and basically comma is separating the two values, or this is like in a matrix or Excel file. And these are the features on the columns, and each row is a different observation or instances. And what you do is, this is the input data. Okay, I will keep changing my statements as we move along. So this is the input data, and the output is to achieve a goal. And mathematically, if we have to think, then we say that there is a function f which has lot of input features, x1, x2, x, and so on, and it gives you an output y. And this y changes based on what is the objective of our problem is. Okay, and the first problem could be that you would like to segment your customers. So you have millions of customers, and what would you like to do is that you would like to understand your clients. How can I group them? Okay, maybe it's too difficult to give a kind of individual kind of analysis or for each customer separately, and you would like to say, I want to make certain limited strategies. So my strategies could be 6 or 7, and to do that, which customer belongs or can be handled by strategy X, and X is like 1 to 6, and so first I have to group my customers. So that's the problem. Okay. Traditionally, these approaches have been handled by non-data driven approaches. Okay, so the first is intuition based. Think like this, that maybe now the school holidays will come, and lot of parents will travel with their kids out of their hometowns. So maybe a travel company will think, now I'm thinking like a typical business analyst. So I'm not using the word business data analyst, but I'm using only business analyst. The business analyst doesn't think based on data. He thinks intuitively. He has certain hypotheses, and he will say, okay, this time people are going to travel, and mostly, rich people travel during with their kids. Middle class and poor people will stay in their own hometowns. They are not going to travel. So I should do is that I go to in Shimla, and let's suppose the people who live near the mall or the Gandhi Road, they are affluent people. And let me put big posters that there is a special package in March and April if you would like to travel to south of India. Okay, uh, air travel plus housing, food, lodging, 6 days package is in 20,000 rupees. Let's suppose, and this is my intuition. And based on my intuition or hypothesis, I start putting posters in that area without thinking about middle class people. So that's an intuition approach. It sometimes works, sometimes might not work. Okay. Then is a historical behavioral data. Okay. Again, the first approach is RFM. Now, RFM stands for recency, F frequency, and M is monetary. And value tier and life cycle I will come in a moment. So what happens is in RFM, recency means that how recently did the customer purchase. This is again a kind of data-driven approach. But not as good as other approach, pure data-driven approach that I will talk in a moment. So what you have is a historical data, and I'm sure some of you might have used Flipkart or Amazon and e-commerce website where you might have bought something. So in RFM approach, the company will say that for me, the important are the recency customers that who recently bought something from this website. And what happens is that, okay, let's take out the customers which bought something in the last 1 month or 2 months. And let's separate them. And this is the customer group I will focus on. And I'm going to send more advertisement. I'm going to target such customers. If the frequency is important, then the company will say that I'm not going to focus on the last 1 month, 2 months, but what I'm going to do is I will think about last 1 year, 1.5 years, and I will see how frequently the customers come to my website and buy something or purchases something. Because maybe a customer might not have come to my website because he or she is busy. Okay, and so in frequency you do like this, and M in monetary value, you forget about frequency and recency. You say that my focus is that from the time of joining my platform until now, present, how much money has been spent by the customer on my e-commerce site. If he has spent, let's say, a customer might not spend, he doesn't come frequently. He has not come in the last 2 months, but whenever he or she comes, it buys very costly stuff, right? So according to RNF, the values are low, but if I look at the monetary value, the value of the customer is very high. So this is like the traditional RFM approach. Sorry. In a value tier, very simple. Very simple. We just say based on the revenue that they have generated, let's only focus on top 1% and top 5% of our customers. And they are the people who are generating most of the value for our business. Okay. Then third was customer life cycle management. Here, different types of customers based on the life cycle stage of the customer. So think like this. When suppose there is a marathon happening in and around Shimla, okay, and so the marathon will start from Gandhi Maidan, for example, and so there is a new organic health related products which has been launched, and this company thinks that okay, there is going to be a marathon, and this is the place where I'm going to do a promotion. Okay, so it puts a banners at the start of the marathon, so that when the runners they start running, they can see the banner. And this company has put a kind of stall near to the registration counter, that when somebody registers for this marathon, the next they see is this stall, and and this company is giving, let's say, free or almost free health related products. And whenever somebody is going there on that counter, it has to fill a small form, that what's the age, the gender, the income, and so on. So when you are doing this registration, you are basically becoming a new customer for that health related product. Okay, and you after the marathon you use it and you really like the product, so either through e-commerce or their physical shop, you start buying this product, and then you become a regular customer of that company. And after 2 to 3 years, whatever, this 2 to 3 years is a very subjective thing. I will come on that. You become a loyal customer of that company. Okay. Now, after that, there might be a competitor of that company, and you might leave and go to the new company. Okay. But for some time, you use this new company's product, you don't like it, and then you return to the old company. So that's your returning phase. So these are the different phases. As I said, this 2 to 3 years, loyal thing is a very subjective thing, because think about telecom. Now, in telecom, generally, now before the Geo came in the market of India, I would say the loyalness of the customers was shorter period, right? Even before people became loyal customers of Airtel, people were switching a lot, right? Oh, this company has a better plan for this month, let's move there. And this company has a new plan, so let's move there. Okay, so in telecom, the loyalness period was very short. Okay, but in companies like bank, once you open a bank account, I think you stay there for maybe 5 years, 10 years, right? I mean, if you look at our parents, once they have opened a bank account in SBI or Punjab National Bank and so on, it's the lifetime thing, right? So I think so the period of loyalness depends on the institution or the company. So you would like to, so coming back, why I have described these different categories of customers based on their lifetime stages is that we would like to segment our customers, right? So we say that let's focus on regular customers through strategy number 1. Okay. And if there is a new customer, we will use the strategy number 2, and so on. So depending on the life cycle stages, you change your strategies. So our objective is customer segmentation. So these are these are, I would still call them semi-data driven approaches. This is purely intuition, and then there is a data driven. It's purely data driven approach. So how an automatic segmentation of the customers can work out based on a pure data driven approach. So think like this, that each dot represents a customer, and these different colors signifies different types of customers. And how can you automatically, in a more I would say machine learning perspective, can segment these customers? So the idea of these segmentation comes that within a cluster, the distance between two data points or two customers should be as less as possible. So when the distance is less numerically, the customers are very similar to each other, right? So the distance is a more numeric, quantitative definition, and similarity is a more qualitative definition of identifying similar individuals or products or something like this. Okay, so within a cluster, the distance should be less, and between two clusters, the distance between, on a generic sense, between the data points should be maximized, should be large. That's the intuition behind how can we segment the customers. So this is a two-dimensional, okay? So two-dimensional space where X and Y are X and Y are features. So X is age, Y is income. So these are two features. You put a data point here that income is this, age is this. Here, age is this, income is low, and so on. So that's how you have put these data points, and each data point is a customer. This is two-dimension. In three-dimension, you can think that there are three features: age, income, and let's say zip code. And so these are three numeric features. Okay, and how can you do it algorithmically? You have various algorithms for that. So what you do is you fall back to these machine learning algorithms like k-means, hierarchical clustering, dbScan, and so on. I'm not going into that, assuming that you know these algorithms, right? So as I said, I'm trying to create a connection between different customer problems, and how can you use existing machine learning algorithms for these customer problems. Okay, I think you know that in k-means, basically, k is a parameter which is given to the algorithm that I would like to create k is equal to three clusters, k is equal to 5 clusters, and you basically have these data points, and let's say in two-dimensional space, you calculate, you select two let's say seed nodes, and then you start calculating the distance between each of these seed nodes, and if let's suppose k is equal to 2, okay, and then you do this iteratively, and at some point the convergence happen, and you say that these are in one cluster, in another. Then the question is, what is the best optimal k? You have these elbow method to find best k, and so on, right? Similarly, you have a different approach in hierarchical clustering, which is being used for a different objective than if the data is non-linearly distributed, right? Because let's suppose this data, okay? So this is like linearly separable. Then techniques like k-means and hierarchically work, but if the data is non-linearly separable, okay, then you cannot use k-means. For that, you have techniques like dbScan, okay, density-based mechanism, and these performs best on this kind of non-linear data. So it boils down to further going in this domain, that what kind of data you have, linear or non-linear, what kind of algorithm you could use. So each algorithm comes with a different different objective, and it all depends on which data fits well for which algorithm. sorry. Now, what are the, just to give you an application of this clustering. So what happening was that at some time back, when a new joinee in the army was coming in US, um, the person has to wait for the uniform. Okay, because even when you go for a tailor, there are certain features, right? What is the breadth of your chest, and how tall are you, that is in terms of height, and so what's the length from your waist to your fits, and so on. Okay, so these are all different features, physical features a tailor has to measure, and then it has to create a kind of uniform which fits well for the new joinee. So the US Army thought, how can we do this? We can minimize this time span while the new joinee is waiting for the uniform. What they did, they basically thought like these are the different physical features, okay, for men and women. And what we should do is that, so think like that, sleeve, back width, and so on, right? So these are only 2 dimensions, but you can think, I mean, as a humans, we can only think of 3 dimensions, right? So think like that you have these 14 dimensions, 14 features, and what they did, they had already existing, army people, and they grouped them into K or N, whatever you want to call it. And they said that these are the maximum different variations that can happen. So for that, you can use k-means, hierarchical, or whatever algorithm you could use. So they used these clustering or segmentation based techniques, and you said these are the maximum groups that can happen. And what we need to do is we don't have to wait. We just already should have among, let's make this n is equal to 20. Okay, 20 different types of, so you bring a new joinee and his size will fit in one of those 20. And what we need is, we do not have to make these very subjective, or let's say custom made uniform, and one of these sides would will fit for this new joinee. And if you see, this is not something new. That's what happens when you go to buy a new t-shirt or ready-made kind of things. They will say we have 5 size: small, medium, large, extra large, extra large, right? So one of these t-shirt will fit to you. So they don't say, okay, come and we will measure your back width and sleeve size and so on, because that's a very good example of customer segmentation, right? So the companies have already done that. Now, what can go wrong? For example, generally depending upon the race or country to country, people in a specific country, let's say in Europe, maybe are more taller or more broader than people from, let's say, East Asian countries. Okay, so but the thing is, if you use those measures and then you apply it in a different country, that might go very wrong, because a medium or large size could be extra large for an Asian, okay, East Asian. I'm not talking about South Asians. So this can go wrong. So you have to consider all these sometimes geographic, demographics information also when you are doing this, import from one country to another. Okay. Now we have seen example of customer segmentation. Similarly, you can do this for product segmentation, right? In the sense that you have, let's say there is a yacht company, okay? So this is a yacht, and it's very famous in South European countries, that in the summertime people go for sailing, or maybe in US. And what you have to do is you basically say that, again, it's a customer segmentation problem, in the sense that you have all these customers, and what would you like to do is you would like to create brochures, okay, like pamphlets, And what would you like to do is that you, depending upon the income, the age of the customers, you would like to say that this particular customer would like this high-end boat, and this kind of customer will not be able to afford, or maybe he wants a kind of yacht which is lower in price, but he wants a bigger one where his family can also come and they go for sailing. So these are the different, again, based on these different background information, you can create segments. And you don't have to create templates of different types. You basically say, okay, these are the 4 or 5 different pamphlets that I would like, or brochures I have to create, and one of them will suit the need of my customer. Okay, yeah. So this was the first data science approach, or where we used for customer segmentation problem. So I'm going to change my gears now, and I will use another different kind of techniques for another business problem. So what we had was customers data. So Estonia is a Baltic country, okay, because there is a Baltic Sea. So there is another 2 countries are Latvia and Lithuania, and again it touches with the Russia. Now these Baltic countries, we have this. Somebody wants to say something? Okay, so please feel free to interrupt. So there is this financial institution. I'm not going to take the name of the bank. We had the project with the bank, and what we had was the access to the real data, and we were physically going to the bank to analyze this data, because it's a very sensitive data. You can't just copy the data of customers and do on your laptop, right? So what we wanted to analyze these online financial transactions of customers from these 3 countries. And what we did was basically use social network analysis. Okay, so this is another technique within data science, which we use to understand the customers, how the customers are interacting with each other. And I will tell you why it's important. Just to understand what this data is. So you had these 0.6 million, 100,000. Yeah, so 68,400. So 0.6 million. So 6 lakh. Yeah, so 6 lakhs in Indian units. So around almost 7 lakhs for all the 3 countries. So if customer A does an online interaction with B, so either it pays or it receives the money, we create an edge between 2 customers. Okay, so 2 customer edge means 2 customers are connected if they are making an online transaction. Could be family, could be friends, could be rent being paid to the owner of the house, and so on. Okay, and so that's how we created these many edges. And then the average degree, that is, degree means how many connections I have. Then I do all these connections for all these people. Then I do an average. That's an average connection or degree. Because not everybody is connected to everybody. So we had this many disconnected components. So think like this, that AB is connected, B is transacting with C, C is transacting with D, D is connected to B, then there is E is connected to F, and so on. Okay, so a very toy example. Now what is happening, that this is your whole network. This is your whole network. But your graph or the network is disconnected. So this is component number 1. And this is component number 2. So how many disconnected components you have? 2. So that's what it means, disconnected components. And the nodes in the biggest component is 4 here, because this is the biggest component, right? So similarly, what are the nodes in the biggest component is this. So basically means that in the biggest component, you have is representing the whole big network. Okay. Then edge density basically means in the denominator you have the maximum edges that could exist, which is, let's suppose if you have n nodes, then n into n minus 1 divided by 2. These are the maximum edges that could exist. And existing means what is present in the network. So if you have, let's say, taking this example, these are 6 nodes. So what could exist? 6 into 6 multiplied by 5 divided by 2. Okay, so 15. But if there are 1, 2, 3, 4, 5, so the 5 is in the numerator, divide by 15. That's the edge density. Similarly, you have a concept of clustering coefficient, which basically, triads. So edge density is between 2 diodes. Clustering coefficient is 3, diameter of the network. So they are basically, graph theory concepts. Okay. Okay. So these are all these graph theory concepts. And if now these are all statistical measures. These are not like something you come of your own. There is a statistical background to these measures. And what are you trying to understand? Now you have these numbers in front of you. You would like to translate these numbers into something where a layman or a non-statistical person can understand. So Estonia, if you look at these average degree, if you look at the edge density, if you look at these clustering coefficient, basically you can get this, and also the diameter. So the diameter is the smallest, right? And average path length is the smallest. So if you look at the numbers, that the largest component, this is the highest in terms of this, right? So don't look at this and this. You have to see it in terms of measures. So Estonia is the most tightly knit community in terms of transactions, which reflects its e-Estonia nature. Now, Estonia is very much like electronically oriented country. Even the voting, you can do it electronically. Okay, you don't have to go physically to do a voting. So last 2 weeks, in the first week of March, there were elections. For 1 week, they had elections. And what was happening for like my office mate, she's Estonian, and she put it 70 plus, who was in India. She 70 plus lady who likes to visit Goa a lot, and she also did it from India, and she did it electronically. So so even for a bank loan, you don't have to go physically to the bank. If you submit all these things, it would be enough. So what I'm trying to say is that this shows that people tend to do things electronically. Okay, but I think still they are not as smart as UPI as we have it in India, right? I mean, still, if you go to these supermarkets or anything, they have these tapping machines, and still Google, Pay and other things are not very popular. So I would say India has done marvelous in terms of UPI thing. It's a very fantastic idea. Okay, now coming back, that you have these numbers, and what we are trying to do here is trying to understand the society, that how can we study the online transaction patterns, and using these patterns we can make something out of these numbers, and these numbers can be used by companies to see that how we should target our customers. So I come back to here. Now in Latvia, you have high clustering coefficient compared to Estonia and very bad in Lithuania. So what it means that think like there is a customer here. It is transacting with two customers. Okay. Clustering coefficient basically means a high clustering coefficient basically means that if A is a friend with B and C, there is a high probability that B and C are also friends. In Latvia, this is very popular compared to Estonia and very bad in Lithuania. Okay. But the diameter of this country or the online pattern is high compared to Estonia and Lithuania. What it means that if you think that this is your big network, what is happening in Latvia that there are small communities which are tightly connected with each other. Okay, which are tightly connected with each other. And then there is a connection here between this. Then there is a connection between here. This is what is happening in Latvia. But this is not the case in Estonia. Estonia could be something like this is the network and there is a community, then small communities. And that is how they are connected. Now, how this information can be used by a company. If a new product has to be launched, okay, this company will say that we have to spend less in Latvia because if let's suppose we call a high influential person in Latvia, then we just give this information here, okay, and I'm trying to use the pen, but somehow this is not working. So, okay, it stopped working. No, but you can see. Okay, so so you have these influential people within these small communities, and that will do the job. So you need to spend less on your product advertisement. But in Estonia, because the community is not tightly, there are not much small communities, so you have to introduce product advertisement in these communities more. Right? So this is how the information can be used by these companies using these numbers. Okay, so this is like a income distribution of these three countries, and basically it's a power law kind of thing. Okay, long tail distribution, and basically you say that most of the people have have less income, but there are few people who are getting a lot of income. Which is like kind of universal thing, right? The same happens in India also. Now we did another thing that how income similarity. That, for example, think like this: I am transacting with 10 people, somebody else is transacting with 20 people. What I did is that take my income and the income of my friends or with people with whom I am transacting. I did a difference. Okay, I will say not the difference, like I did an average of my friends and I did a minus or a subtraction or a comparison with my income. So the average income of my friends and my income. And that's what I did the difference. And this I did for all the customers in the bank. And then I see how differ they are in terms of their income. So what we find out that most of the people try to transact with higher income people. So this was another thing. Can we use this network information in a different thing? You can use it. We try to use this technique on there was a datathon some years back. We use this information how to find corruption in companies. So there were some companies which we red are the companies which we knew that involved in corruption. Okay, they declared themselves bankrupt, and we say that what were the other companies with either their other peer companies, or they created their subsidiaries and so on, and they transferred the fund and then they declared themselves as bankrupt. Okay, so we created this kind of different patterns that existed in these corruption based companies. Okay, to be honest, we couldn't find a very kind of discrete information that yes, this is there, because companies were using all kind of mechanism. But what I'm trying to say is that now we have a kind of template which we could use, that one of these things can happen. So it's not like only this thing happened. A corruption pattern could be something like this also, for example. Another network things that Enron thing, I don't know, you know about this. So there was an Enron company, and it went bankrupt at some point. And what we are doing is that here you see the from 2000 to 2001, you are seeing the email interactions. Okay, you see that okay, in 2001, lot of anxiety turns up between the different levels of so the different color of these nodes basically shows the different level of or hierarchy in an organization, that more and more people started emailing each other. Okay, so what I'm saying is that data science, network science or social network analysis techniques, which is a kind of data science technique, can be used to study something related with financial institutions, and this could be used for studying customers or anything within the business setting as well. Okay, so again, I'm changing the gear, coming back to more like a machine learning perspective. Customer lifetime value. Okay, customer lifetime value basically means how much value a customer can bring during his or her association of lifetime with an organization, and the companies are very much interested in that. Okay, so how can we do that? So think like this, that there is a customer which has bought 2 products, another customer bought 3 products, another 5, another 6 products, and think that then these products are very high-end value products. Okay, so this person, when bought these 2 products, brought, let's say, 2 millions and so on. So basically it means that corresponding to the number of products they bought, value they have generated for the organization or for the bank. Now think that there is a new customer which has bought 4 products, and you would like to predict, or you would like to understand how much lifetime value would be of this customer for this institution. And basically, if we create a line, which is basically what we did just now, is a kind of a linear regression, right? So we are just plotting the data, but the data, we know that is not as good as what we saw in this case, right? So for this problem, what you could do is that you could use the linear regression, right? So in customer segmentation, we use this unsupervised learning. Why we are calling it unsupervised learning? Because there was no label, there was no ground truth available in the data. Okay, so when you say that X and Y, age and income, are the 2 features, what we did, we just wanted to create clusters, right? Whether these clusters are good or bad, we don't know. Of course, there are techniques which can help you in evaluating the quality of these customers, like RAND index. Okay, I'm not going into that, but there was no ground truth which you could have used. So that's why there is no supervision, and we call them unsupervised. If you have the ground truth, if as in the previous case, here you knew these 4 customers lifetime value, you knew about. This is the ground truth. Okay, this is the label you have. Sorry about my handwriting. So that's why we call it supervised learning. Now, in supervised learning, there are mainly, of course, there could be semi-supervised and other things, but in broadly talking, in supervised learning, you have 2 categories. You have a kind of regression kind of values. For example, what is the value of the customers, right? So when we say the value of the customers, it's between theoretically 0 to positive infinity. Theoretically, it can lie between anything, right? And this is a continuous value. And to handle such cases, you go for regression or regressors kind of approach. Okay, a problem like how much this. So I mean, generally, if you think about real estate market, and we go for a broker, how the broker, I mean, in small, in small cities or B towns, brokers have everything in their mind. They know that in this locality, this house can be, you can sell this house in this value, right? That's a regressor working in their mind, right? But think about companies in Delhi or National Capital Region, NCR, right? Noida, Gurgaon, and so on. There are real estate companies which have, a kind of information in their databases, and you would like to, predict what would be the value of this house would be, because it's from this, blah blah builder in a blah blah road. It has a kind of park facing, 3 balconies, 4 bathrooms attached, and this much square meters. So all these are features, right? So how much the value of this house would be, again, it's a regression problem. But if my question becomes that whether I am able to sell this house in next 1 month, yes or no, it becomes a classification problem. Okay, so if I am classifying into yes or no, here binary classification. Okay, you can have more than 2 classes, then it's called multi-class classification, but we will just stick to binary classification. So if you have values, let's say between 0 to positive infinity, or if you have between 2 classes, your strategy changes. You either go for a regressor or you go for a classifier. So that's the 2 kind of supervised learning. Supervised learning means basically you have the ground truth. You already have the data, you already have the label, and this features plus data is given together to the models, and models learn based on the features plus labels. Mathematically, what you have is in supervised, you have, let's say, features xi and the ground truth y, and in unsupervised, you only have the input features xi, and you don't have the ground truth, right? So, and one of the important, I would say, kind of learning is that you divide the data into training and test set. You basically never show what your training is. I mean, this doesn't happen in segmentation. Okay, this is a pure supervised learning concept, that you divide the data into train and test. You create your models here, and then you evaluate your models using your test data. Okay, so what I'm going to do is, now I'm going to talk about different problems from real world that we did using which are related to financial institution, and these are different. How good or bad they are, that's fine. And what we thought about, let's try to understand how well the film or a movie performs at the box office, right? And what we had is that a lot of movies that we kind of gathered the data from, and from Hollywood and also from Bollywood, and 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 what we had was that also Twitter data, okay, which basically shows the wisdom of the crowd, and then we also had exports data, okay, and the budget and other things of the movies, and the prediction was the box office outcome of the movie. So I'm sure you know that as soon as we say the box office outcome of the movie, we are basically translating into a regression problem, right? Because the box office outcome basically means that how much movie was able to get the value at the box office. So there were total 533 movies. I know it sounds like a very time for us, and we use three machine learning algorithms: linear regression, random forest, and XGBoost for regression problems. Um, and what we had was that 2015 to 18, we had all the movies, not all movies which were released in between these years, and movies which released on Fridays only, because some movies get released during the holiday time, even on Thursdays and Wednesdays also. Wide released, that is 600 and more cinemas. No such tool was there for Bollywood. Then we collected, using unique hashtags of these movies, and we basically have, around more than 1 terabyte of data of these 4.3 billion tweets. We also had expert reviews and so on. Movie revenue information came from these websites, and after cleaning, it became this much: 347 and 186 in in Bollywood. And as you can see, that some of these features are non-structured. Okay, so what is like from Twitter, we had this hourly rate, sentiments, polarity, and their subjectivity. But this is more like a structured data, but it came from unstructured data, right? Because the original Twitter text is a unstructured data. So for metadata, we have budget, opening theater counts, and parental rating, and so on. So we applied a standard machine learning approach, that we had these data sets. For Hollywood, the training was 318 plus 170. The test was this. We had this feature creation. Let's focus on the training part. Then we created these different 4 models, and then we had these 3 algorithms, and then we did it key folds with k is equal to 10, validation. These are very standard machine learning steps, right? So I'm not going into elaboration because, as I said, that I assume, or that's I have been told that So you create this training model, and this model is recreated, and then you do some feature creation from your test data, and you give it to this training model, and you just evaluate. So we because it's a regression problem, so the metrics are for a regression. So we did this R square and MAPE metrics. Obtained was this for this model, that is metadata plus critique, and for linear regression with a value of 8.63, which is not very far from XGBoost of 0.862. Just a small comment, we believe sometimes that these new ensemble based, relatively new ensemble based methods like XGBoost, as you see here, these linear regression has performed better than XGBoost and random forest. So, okay. So in terms of the evaluation metrics, random forest gave the lowest error. Okay. So it depends, like what is your of the model, okay, or you are focusing on the error part. So now coming back, what the difference between supervised and supervised? I think I already kind of explained that the process remains the same, with only the ground truth which differs, and what you have is a regressor here and a classifier here, and in basically in case of classifier, you don't get actually the yes or no. Like the classifier never tells you that it belongs to this class or that class, except for KNN. Okay, except for KNN. KNN tells you whether it belongs to yes class or no class, one class or zero class, but other algorithms basically gives you probabilities. Okay, and then it's somehow your job that what is my threshold, and above this threshold is going to be this class, positive class, and below this threshold is going to be my negative class or zero class. And that's how you create these two classes. Okay. I'm not going to describe this. Now let's take a problem of another business problem is churn, right? I briefly touch upon it, which is, when a customer leaves. So in telecom, when the Geo came in the market, I think we all know that almost everyone who had a smartphone moved to Geo because it was giving you at a very cheap price lot of per day data, right? And everybody turned into Instagram, Reels, TikTok, and whatnot, right? So a very big churn happened from Airtel, Vodafone towards Geo. So when a customer leaves their organization and moves to another, this is called a churn. Okay, so the churn happens in event-based things. Let's suppose you go to you live in a certain locality in Shimla, and you are staying in let's say Shastri Nagar or I don't know about, as I said, but I'm just coming up with the names. And where you usually buy your groceries, that Varmaji's and Guptaji's shop, and you go there to buy certain stuff, right? Now you usually go Guptaji's shop, but suddenly say Varmaji's shop is a newly opened shop, and it gives you a cheaper price for some reason. Okay, now you basically stop going to Guptaji's shop. A churn has happened, right? But if you are let's say if you are just a newly a bachelor student who has just enrolled in Shimla University for a certain course, maybe Guptaji will not observe, right? So this is an event-based thing, which is not usually traceable. But if, let's suppose, you are in telecom, or you have a bank account, and suddenly you realize that SBI's service is not good, but there is a new bank, HDFC, for example, and it gives it's a private customer, and the people are good there. They give you better service. They even come to your home to if you are not able to go to their bank physically, so you like their services and you move. So when you close these bank accounts from SBI and move to HDFC, there is a churn which has happened. And since there is a proper subscription, that is a card, or through telecom, that you stop using your Airtel and you move to Geo, there is the churn is very, very, noticeable. And this is what happens in subscription based. Okay, so what can you do for how can you detect whether a churn has happened? You can again use different kinds of machine learning algorithms. So in regression, you have linear regression for classification, because churn means a churn has happened, yes or no, right? So it's a binary classification problem. So it's not a continuous value, it's a discrete values. So for that, you need classifiers, random forest, and other gradients boost, which are black box in nature. Not purely, but yes, to much extent. So these algorithms, but we also use them for regression, but you change some parameters, and you can also use them for classification also. And then other white box techniques like logistic regression and decision trees. We call them white box because they are interpretable. You know what features, the weights of the features are important, because you can get these through models, right? Same in the case of linear regression. You know what's the coefficient values of these values, and that makes the model interpretable. Okay, so you can use these classifiers to predict churn. But what I'm going to do is that, again, I'm going to talk about briefly a problem that we worked on with the bank. And the problem was payment classification. So think like this, that you go to some shop, and we don't know, the bank doesn't know what kind of shop the customer has made a payment for. And the bank is very much interested in knowing what is the type of this transaction is. Because once the bank knows that what kind of transactions you are making, then it will help the bank in making these transaction, and then it can give that kind of advertisement to the customer. For example, if the bank doesn't know that I'm more of a foodie, okay, rather than of, let's say, I'm more interested in going to restaurants rather than buying clothes, then it means it makes sense from the bank side that it tells me more information about that. Okay, in this period, if you go to a certain restaurant, I will give you 10% discount. That kind of advertisement I would be interested in, rather than bank telling me that, oh, there is a clothing sale going on and you have 20% discount. I don't like. So this kind of, let's say, targeted advertisement is not good for me, right? So that's why the banks are very much interested in knowing what kind of transactions I am making. Sometimes it's not easy for banks to know that, because, as I said, there is no UPI here in Estonia. What you have is this physical machines where you go and tap your card. You go to a supermarket, you go to a certain shop, and there is this machine where you tap your card and you give the payment. Now, these machines not always belong to the banks. They could be belong to other bank. So the shopkeeper might not keep these machines which belongs to the same bank which I am customer of. It might have a machine of some other bank. And if the machine is of some other bank, then my bank will not know what kind of thing I have made the payment for. So that's the context and the background. So I hope that is clear, that this is a scenario where the bank will not know for what I have made this payment. Okay, so now the bank wants to know. And why they want to know? Because then they can do a targeted advertisement. Okay, now what we did from the bank where we partnered with, we had 12 months of data. Okay, and from three, again, Nordic countries, and so many millions of transaction, more than 200 GB of data. We had two kind of transactions, that is account payments and card payments. Now, what we would like to do a classification is whether the payment is food, healthcare, travel, household, and so on. Okay, so this is not a binary class. This is a multi-class problem. Okay, and so basically, to why would you like to do that? Because you would like to recommend products or advertisement. Okay, so I think I missed those slides which kind, but let me tell you what we did. Okay, we had a bootstrap mechanism approach. Now, in bootstrap, what we did that in case of online transaction, the bank will know. Okay, but in case of card payments, the bank might not know. So what we thought that we had this kind of hybrid mechanism. Okay, in hybrid mechanism, if we don't know anything about the customer, then we go to the popularity based approach. Okay, we say that what is the most popular things people buy, and if the people are buying mostly they're going to supermarkets or food related, that's what we're going to advertise about it. And if we don't, if let's say, if we know something about the customers, okay, let's suppose the customer has spent 2 months of time with the bank, then in 2 months, whatever information we have, then we use that popularity. First is the overall popularity. Once that bootstrap phase is gone, then whatever time we have spent with the customer, whatever he or she is doing the popular transaction, we will use that to predict. And if we do that, and then once we know more and more information about that, let's say metadata, income, and so on, we use that information along with the limited transactions that he or she is doing. We use that kind of thing. So it was more of a hybrid mechanism. And what we turned out that we had AUC ROC, which is I hope you know, this is one of the evaluation metric we used to evaluate the model, right? Area under the curve, receiver operating characteristics. Okay, this metric is basically used when you have unbalanced data. I mean, you can use it in a balanced data also, but this is the metric which is used compared to even accuracy and even F1 metric. This is a more robust metric. Okay, now this is a kind of last bank or let's say financial institution customer problem that we will look at. Banks are already making profits. Okay, now they would also like to recommend something more. They would like to sell more. Okay, and that is the whole idea in cross-selling and upselling is. So if you go to a McDonald's and you say that you have only one thing in your mind, that I would like to have these burgers and that's it. And then the lady at the counter says, would you like to have potatoes? So what basically she is doing is that she's doing cross-selling. Okay, that and she says that, okay, the burger costs, let's say 20 rupees, but if you buy potatoes, instead of 10 rupees, we will sell you in 5 rupees. Okay, so I mean, I'm just coming up with figures. I don't know how much price is there in McDonald's. So Amazon shopping, what happens is that when you would like to buy a new smartphone, okay, so your target is this phone, which might cost, let's say, 20,000 Indian rupees. Okay, and what you see is that but below it start showing you that this is your main thing. This is your main thing. And it also starts you showing that if you buy this, we also have, let's say, 500 rupees headphone, it's a 10% discount. So what this e-commerce site is doing is a cross-selling. This is your main thing, and this is your cross thing that you are trying to sell, which is much cheaper than the original item, but which also sells you 10% discount. Okay, that's a cross-selling. I'm not going into the definition. It's a related and complementary product. And it's a very usual technique by companies to generate more profits. Okay. Now, Spotify. Now, with free, without anything, you get this, only shuffle, play, and so on. But if you pay this much per month, you get all these features. The product is the same, Spotify, nothing extra. But if you move from free to premium, you basically start paying and you get all these features. This is called upselling. Okay. Another example could be that you have to do and travel from, let's say, let's say Delhi to Chennai. Okay, and you're moving because you got a job there, and you have, in the usual case, there is only 123 kgs allowed. But if you go for a premium or from premium to, let's say, business class, you get 223 kgs. Okay, so this is another example of upselling, where what is the objective here? You just want to travel from one place to another. The seat, you are occupying one seat. But if you go upselling or go from premium economy to business class, you get extra features. Okay, leg space. Okay, the quality of the seat, and so on. All these things changes, right? So this is an example of upselling, and these are two ways through which these companies, try to make more profit. Now, how can we solve this problem? There is a thing called recommendation systems, and we will see some of these techniques very quickly. How can we use these techniques to recommend these products to customers? Okay. What are the different products? So there is this popularity-based mechanism. Then you have market baskets analysis, and then collaborative filtering. We'll talk about them briefly. Think about a physical shop in the main market in Shimla, and in the main market in Shimla, space is the problem. If there is a bookseller, what kind of books he or she will keep there? Maybe books like Harry Potter's or other things which are very popular, right? Let's suppose there is a book which is not so popular, okay? And but still, sometimes, rarely, customer comes and they ask for that book. And so what this guys does, it has a bookstore outside, Shimla, and it keeps all these books there which are not so popular. That's the physical thing, and that's what happens in terms of popularity, right? So there are very few books which are highly popular, and then there is a long tail of books which are less popular. Okay, so the goal of the recommendation system is to identify such products which are relevant to the users, right? And where do we see these recommendation systems? In multiple platforms. Like LinkedIn, you get recommendation for the jobs, right? So that's a recommendation engine. In Facebook, you get recommendation for friends. I don't know how many of you still use Facebook, but now new generation has moved to Instagram and things like that, right? And then in platforms like Amazon, where you have books and other stuff which you can use. So these are all recommendation examples. So the popularity based, what happens is that when you open Google News without logging into Google, what you see is the most popular news. Okay, but once you logged in, then you might see different news. But let's suppose you have not logged in. So what you see is the popularity based news. Okay, so it's a kind of recommendation system news, right? Similarly, when you open an e-commerce site, a male might see things like this. Okay, which might not be, a man might not be interested in wearing these kind of things, but it still sees because they are popular. Okay, so sometimes popular things doesn't make any sense. For example, when we did this in Google, two most popular products, we see all these things: smartwatches, video doorbells, and I do not understand what is the relation between smartwatch and, let's say, video cameras. Okay, what is the association? So if, let's suppose, you would like to recommend two products to your customers, the two most products popular, they might not be relevant, right? And that's how we try to find solution through market basket analysis. Okay. Um, um, nappies and beer. So I don't know if you know this, a very big study by Walmart, which is a very big supermarket chain in US. If I ask you that, people who have bought nappies for kids have also bought beer. Now, these are coming from two different worlds, right? So it doesn't make any sense. But if I tell you that people who bought bread also bought butter, right? Makes sense that you apply butter on the bread, and it makes sense that you keep these two things next to each other in supermarkets. So people don't have to, spend too much time in supermarkets, so the more and more customers can come in the supermarkets. So the companies are always interested in that. Now, nappies and beer. Okay, now doesn't make any sense, and this makes sense because what happens when the Walmart did a business data analytics study? What it did was that it from its data, it tried to understand that people who have bought nappies also bought beer, because in supermarket, when you are buying products, you have these things that there is a transaction, and in which transaction which of the products went together. I have just 5 minutes more, but maybe if you don't mind, I will take maybe some extra minutes. I hope it's fine. Okay. Okay, but feel free to interrupt. I will stop at any place if I'm overshooting the time. So the idea is that I will tell you later how it was done. But what happens when they ask the customers, they did a survey that whether these actually two things are together. They found out that the newly married people or the couple with babies, the guys wanted to have beer during the weekend, and females, they were mostly interested in buying nappies for the newborns. And what they did, that after they found this in their data and that confirmed with the these couples, this, as soon as you enter in the supermarket, in big supermarkets, you see that there are certain products which are kept next to each other, might not make sense, but they don't want, because these are very popular things, may not be related, and they want people to pick and buy these important things and put them in their basket, go around, buy other stuff, and leave the supermarket. So that's why you see, this is the idea of these supermarkets. Okay, how it happens. So what you have is a kind of transaction. Each transaction, let's say, beer, diaper, chips, aspirin, and another transaction, somebody bought diaper, beer, chips, lotion, and so on. Okay, so diaper basically means nappies here, another transaction, and so on. So these are 6 transactions. What you have is in market basket analysis called support. Okay, so frequently based items. So then there is a things called lift. So these are the terms or techniques, which you use to find frequently bought items and with some minimum support that I'm not going into the solution that how you calculate it. And so then there are metrics like lift to check whether these sort into items, let's say so you say that A is equal to B and A is equal to beer and B is nappies. Okay, you say people who bought beer also bought nappies. So what you have to do is you basically are checking for this pattern. Okay, so and once you can do this for, and the technique you have is association rule mining. Okay, association rule mining. This is the technique which you basically use it. Okay, so sometimes you would also call it market basket analysis, and this is again an unsupervised machine learning technique which you use to find patterns. Now, what is the problem with this? Now, if somebody is vegetarian, okay, somebody is vegetarian, and you say that, and he doesn't drink, he or she doesn't drink, and you start saying these are our more popular products together, and you start recommending them, they might get offended, right? And a vegetarian person, if you say that we have very popular meat chicken products which are very popular, and people who bought this chicken product also bought beer, you're offending the person. Instead of getting more customer, people might not come to your supermarket anymore because they felt offended. So what it means that market basket analysis technique or association rule mining can find two products or more than two products which do make sense, but there is no personalized recommendation thing here, right? And to tackle that, you need this collaborative filtering, which I will talk in a moment. So when you see that, when you go to these Netflix or other people, so these companies knows what kind of movies you have watched, and what they do is basically they try to see that what kind of movies you watch, and they try to identify similar people like you, and then they say people who watch Love Simon have also watched similar movies. Okay, and or people who have, let's say, in terms of food item consumption, they will say that okay, people who bought a vegetarian things dish have also bought this kind of healthy lemonade drink. Okay, so this is a personalized recommendation which is missing in market basket analysis. And market basket analysis, the compared to popularity, which is based on only popular products but no associations between the products, and this is tackled by market basket analysis. But in market basket analysis there is no personalized recommendation, and that is overcome by collaborative filtering. And how collaborative filtering came into picture? There was a Netflix challenge, and the idea was that how can we recommend, it came in 2009 with a very big amount of price, and that's how this technique came. That in collaborative filtering you have two types. So one is user based. What happens in user based is that you have a new customer or whatever customer, okay, you have a certain buying pattern. You like to find, you like to buy certain products, okay, and based on your buying patterns, we identify a similar customer to you and says okay, he has bought a watermelon and strawberry, okay, this person, and we find this person who has bought strawberry and also watermelon, but this person also bought a orange and grapes. So what we do is, since we identified similar users So whatever extra things which this person has not bought, we start recommending these new things to this customer. And that's how this user-based collaborative filtering works. Similarly, you have, this is almost the last slide. Similarly, you have item-based filtering. What you do is, instead of user, you try to identify the items. Okay, so what you have is that this person likes, let's say, a certain items, or we have to recommend a certain items, and we say, okay, this likes watermelon. Okay, this person likes watermelon. Watermelon is similar to grapes. Even if it doesn't make any sense, just assume it makes sense that watermelon is similar to grapes. So what we are doing that here, we are recommending grape to the, which is a similar item, to the person. So that's an idea of collaborative filtering. That's how the personalized recommendation system works. So to summarize, we looked at various different kinds of business problems, and we looked at how different data science techniques can be used to solve these different business problems. Okay, so I would like to thank my collaborators for some of these research problems, and and um, and that's it. I hope I finished almost in time, right?
Yes, Dr. Rajesh, you are bang on.
Okay, so if you have any questions for me, please let me know,
Anybody
or any feedback or comments.
Thank you, sir. Sir, can you shed some light upon how elections are done in Estonia, and what is the role of artificial intelligence, and how does the security breaches are avoided? Because we know elections are a very delicate process.
Okay, very good question, but I'm not from a security domain. Okay, so I'm not the right person to comment on, because as you yourself said, there are two aspects. One is the privacy, other is the security, because nobody should know which political party or person I'm voting for, right? That's my privacy. Other thing is that the security. I mean, whatever I am voting for, it should not be kind of breached by some security, and the voting goes to some other things. So, as I said, I'm more of a data analyst, social media guy, and this is not my area. I'm really sorry, I cannot answer that question. I mean, I'm sure there are different mechanisms, like could be, I don't know, I'm just speculating, could be blockchain and things like that. But I don't think I'm the right person to comment on it. Yeah.
Thank you, sir.
Thank you. Any more questions? Yeah, please ask. Yeah.
So, is there any way political parties segment their voters into different groups?
Can you please repeat your question? Is there any political party?
Is there any way political parties segment their voters into different groups?
Oh, very good question. Very good question. Um, do you know this Obama election? I think before 2016, because in 2016 Trump came. I think I'm talking about 2012 election, when Obama came for the first time, if I'm right. Okay, so there is a thing called uplift modeling. I don't know if you know this term. So what this is a very new thing, uplift modeling, and companies use it a lot. Now, uplift modeling is a technique. For example, let's take an example that there is a bank, uh, and bank says that if you wear a pink T-shirt, we will, open a free bank account. Now, I mean, it may sound like a strange example, um, but I think it could make sense that I don't know if you know that lot of uh, it's not fair to say that, but lot of uh, pink color is associated with LGBT people, right? Gay people. And if you ask a macho guy or a macho guy that let's go to rich or let's say there is a stall of a bank which is giving free pink t-shirt and it opens a bank account, this macho guy who would have gone to open a bank account will not go because they are giving you a pink shirt and they say, oh, I don't want to sound like a gay guy, right? There are some kind of non stereotypical things. And so instead of attracting the customers, what the bank did, it basically kind of throw away the customers. Okay, so it kind of pushed back the customers by introducing this pink t-shirt idea. uh, Now, what ideally should happen when somebody has to open a bank account, they should target with this pink shirt only to people who actually appreciate getting pink t-shirt by opening a bank account. So it means people who would not have opened a bank account without pink shirt should be given this pink shirt. I don't know if it makes sense, but let's come back to the Obama's election. So you can put your customers, not customers, your voters or so-called voters into four groups. People who are Republicans. So Obama was a Democrat, is coming from a Democrat. I don't know if you know about US elections, but there are two main political parties, Republicans and Democrats. So Trump is from Republicans. They are kind of right-wing. And then you have Democrats like Obama, Hillary Clinton, they are all from Democrats. Joe Biden is from Democrat. Okay. So Obama was a Democrat presidential, now, what happens is that there are certain Republicans who will never ever vote for Democrats, right? Even if you go and give them Porsche or Ferrari, they will never come and vote for, for Obama. So it doesn't make any sense to go and convince them. That's a part of group that you should never target. Okay. Then there is a group which is pro-Democrat. Whatever happens, even if Obama does something wrong, they will still go and vote for Obama. So even if you don't spend time, or even if you don't go and spend, convince them, they will still come and vote. So these are the two groups which you don't have to put efforts because they are already going to vote or not vote for Obama. Now, what are the two other groups? Two other groups are that one group that which is still thinking to vote for Obama, but if you go knock their doors more than 2 times, they might feel irritated, say, I don't want to vote for Obama. If we get irritated. Okay, so that's another segment. And then there is another segment which is still kind of 50-50, but they might go and vote for Obama and they might go and vote for somebody else. But you need to convince them to vote for Obama. And the idea of uplift modeling is to target this kind of voters, which are 50-50, but still they need another push. They need to be convinced. And that's the idea of uplift modeling was. So if you Google about Obama elections, you will see how uplift modeling was used in Obama's election. Now, how can we translate into customers? Same goes for companies. There is certain loyal customers which will never leave a company. There is a certain group which will never come to your company, whatever you do. Then there is a customer which should have come, but because you give them the pink t-shirt, they will never come. But then there is a customer maybe from LGBT, but maybe their girlfriends convinced them that go and this is a pretty cool, open-minded bank, LGBT supported. So they needed a push and they come to open a bank account. And that's the customer base companies have started focusing on by using this uplift modeling technique. I hope I answered your question.
Yeah. As a sequel, Dr. Rajesh,
Yeah, please.
as a sequel, could you throw some light on the elections in Indian context, recent Lok Sabha elections, 2019? Do you think some kind of social networks were being used to influence the voters based upon your segmentation theory?
Yeah, I mean, I don't know whether we should actually focus on segmentation theory, but I think what we know is that social media plays an important role in elections. Social media plays not only an important role in elections, but also in other problems like protests, for example. I will come back to your question. So what we did is that we analyzed CA protests. I hope you know this Citizenship Amendment Act, right? There was a big kind of protests which happened especially in Delhi and some other parts of India. So what we did that we analyzed. We are not saying whether it's right or wrong, but we collected Twitter data and we analyze this data. This paper is already out, and we have two more versions of this paper. I mean, this topic. That how people who were following a certain, like who were pro and against, what were the main topics. So we segment these Twitter users based on whether they were pro CA or anti CA, and then I will talk about election in a moment. So people have a thing called stance. Stance detection is basically whether they are support or against a certain thing. So first you use this stance detection techniques, which are again machine learning AI based techniques, because you can't manually detect stance of people. So anyway, so you do this stance detection and you divide the users into pro or against CA. Okay, once you have these two segments of people, then you try to what we did, we try to study what were their topics, what were the topics that they were both talking about, how the sentiments were used in each of these groups for pro and anti and so on. Okay, how was the network, that is for example, if there is a pro user, pro CA, and how his followers were creating were kind of retweeting, how the anti CA were creating the network. So what we saw that there was a kind of, we think with concept called echo chambers. So echo chambers is something like if you watch, let's say a YouTube video from, let's say, from a certain political party, YouTube start recommending you more and more such videos. So what happens basically, you are being echoed. You go in a chamber where you are echoed same kind of information, and it eventually makes you more polarized towards a certain political party or a group or a stand, which is not healthy for the society. Okay, coming back to that, we saw using network analysis that there was an echo chambers, that pro users were not following anti users, anti followers were not following pro. So it means whatever stance I have, I will just follow people whom I like. And that's not healthy, right? So we saw this kind of polarized thing. Now, in this next work, we are trying to see how hate speech was used by both sides to instigate their followers, to bring their followers to the online social media. Next is how misinformation was used. So now coming back to the elections, I think let's take an example of Twitter, because Twitter we can easily relate to. So what happens generally is that I think platforms like Twitter and Instagram, maybe I don't follow Instagram much, but I think on Twitter, you can advertise about your schemes. What we see is that people who are following a certain kind of political parties, they tend to follow and listen to them. They are less prone to listen to other political parties views on the certain event and topic. I think for a society, the policymakers or the government should introduce some kind of interventions. Interventions means, for example, creating policies that these big social media platforms should not create a kind of echo chambers, because that leads to a more polarized society. Because as a normal human being, and also from the perspective of social media platforms, the main problem is they would like to keep their customers engaged on the platforms, because that's how they generate revenue. So it's a profit driven platforms, and to keep their customers or people engaged on the platform is to show them what they like. But in the due process, they make their people more polarized, which is not good for society. So the government or the policymakers should introduce some kind of interventions that after showing 4 videos of political party A, there should be a new video from political party B. I mean, how it is possible, that's out of my hand. But yes, the platforms have been heavily used by these parties, and I think these political parties also use kind of to segment, or let's say to create a stance that if a certain user who is liking a certain post or retweeting a certain post, who has a number of X number of followers, they can become influencers. I think this is also used by political parties to set their agenda. Yeah, I don't know if I answered your question.
Thank you, sir.
And there was something in the chat also. I don't know if.
Yeah, I think chat में कोई question है क्या? Is there any question from anyone?
Yes, sir.
Please. This is the last question, I think, from our side.
No problem.
Good news, sir.
Hi.
Wait a moment.
I have heard this word so many times, so I just want to know exactly what is the connection between these two. Like computational sciences and cognitive sciences. What exactly these two are and how they are interlinked?
Okay, let me repeat your question. What is the difference between computer science and computational science?
Computational sciences and cognitive sciences.
Okay, so I'm not from a cognitive science, but whatever my limited information is, that I will tell that I think in computational social science, we are more interested in using computational techniques. That is, it can come from machine learning, data science, NLP, AI, social network analysis for societal issues or topics which has traditionally been looked by social scientists using survey-based data, interviews, questions, or very